it's Ms. Smith. So today we're going to talk about a little bit, we're going to go more into numbers because the whole reason why I go over how to deal with data and significant figures and scientific notation is because you will use these skills throughout the rest of the year. So we need to master them in the beginning. So today I'm going to talk about the difference between accuracy and precision, and that's actually really important in a chemistry setting because if your measurements are not accurate and precise, it literally, your experiment can kill you, okay? We, normally in a classroom setting, we would be dealing with different things in the lab that are actually very dangerous. I train you for like a whole week at the beginning of the year to how to do things safely in the lab. But if you're not accurate and precise with your experiment, things could go very, very wrong. So it's important in a chemistry setting. It's important really in any science. So especially if you're doing any kind of research. So you need, when you're doing research, you should be running multiple trials, and your trials need to be accurate and precise. So anyway, I'm also going to talk about accurate precision. I'll talk about unit conversions. And so we're going to start out with some basic conversions, very simple today, very easy. It's not too difficult. Tomorrow we're going to get into multi-step conversions. Those are a little bit more difficult, but you can do them. It's going to be okay. All right, there's a lot of people that get really frustrated with unit conversions because they feel like they can't do it. Okay, I'm going to slow it down. We're going to take it step by step. I will give you some tips and tricks on what to do. You're going to be just fine. All right, so I'm going to my notebook here, and first thing I want you to write down is the official definition for accuracy and precision. And then I've got a couple of pictures, not precisions, look at me, precision. So accuracy, I've got a couple of pictures here in a minute that I'm going to put in here, and they would be really great for you to draw in your notebook so you have a future reference. So the definition for accuracy is how close to the target. And I'm going to use actual targets when I talk about accuracy versus precision. So this will be our bullseye. Now, precision is your grouping of trials. Okay, remember that when you're doing any kind of research, especially in a chemistry laboratory, any kind of laboratory, you need to do multiple trials to make sure that your results are reputable results and they are consistent. So your trials need to be precise because it means that your data that you get is pretty close together. You're getting the same thing for all of your trials. Now, I'm going to bring in a picture, this one here, and this would be fantastic for you to put in your notes. Go ahead and draw. So I'm going to blow this up. Oh, oops. We don't need a little one. There we go. Okay. So this would be fantastic for you to write down in your notes. So I'm going to zoom in a little bit so you can see this a little bit better. So we've got 4 different scenarios here. So you see on each target we have several dots. So on the first trial, this one here, number 1, I'm going to go ahead and number these so you know which ones I'm talking about. On the first one, you have all of your trials on the bullseye and close grouped together. No, grouped close together. There we go. So that means that you have high precision and high accuracy. High accuracy is going to be hitting the bullseye. So almost every single one of these hit the bullseye dead on. So that means your accuracy is high. Your precision is how are they grouped together, and these are grouped together very closely. So that means that I have high precision. Now on the second one, they're kind of grouped around the bullseye. So we were, let's say that you were shooting a gun when this was made. You were shooting at a target, and these are bullet holes. You were aiming for the target itself, like the bullseye, but you weren't consistent in your trials. Your trials were not grouped very well. So you have high accuracy because all of your bullet holes were close to the bullseye, but you have low precision because they're spaced out. Now on number 3, I have my grouping is great. They're all real close together, so that means that I'm going to have high precision, but they are not on the bullseye, so that means that I have low accuracy. Now in number 4, they are not grouped together at all, and they are not on the bullseye, so that means low precision and low accuracy. So now what I'm going to do, now that we've talked about that, if you need to pause the video so you can finish drawing this and getting your notebook, go ahead. Pause it now. So now what I'm going to add another picture, and we're going to talk about how you would actually see this in a laboratory setting. Okay, so here's an example. Let's say that you did this lab, and for example, one of the things that I do, there's a lab that I do when, if we were in a regular classroom setting, where you have to weigh the beakers before you start the experiment, because if your beakers weigh differently, it actually messes up your data in the end. So let's say that you weighed the beakers, and this is the data that you got. So if you look here, your goal data that it should be is 1 gram, like straight up 1 gram. There's a whole lot of decimal places out there, but it says to be 1 gram. So let's look at this data set A. This is, let's see, that first one is pretty far off of 1 gram. This is closer, so that's a little bit closer. That one's way off. This one's a little closer, and this one's a little closer. So I'm going to say that data set A is low precision because none of them are close together. And I'm also going to say low accuracy. Okay, if you had something that was like 0.9959, 0.5965, 0.9999, if you had a whole bunch of those grouped together like that, then it would be high accuracy, high precision. But these are not close to the goal target. They're pretty far off, actually. Now, this one here, all of these are 1.31 and the last couple of numbers are different. Okay, these are all very close together. So I have high precision on that one. But if you look at it, it says to be 1.0. These are all 1.3. That is low accuracy. That is not even close to what it should be. Okay. So that's the basics for accuracy and precision. So I'm actually going to go to a new page. We're now going to talk about units. So, oh, that's black. I need to put that in black, not red. Okay. So now I'm going to talk about units. All right. Now, in any kind of science-related field, let's say that you did research and you found the cure for cancer. You did all this research, you figured it out, you found the cure for cancer. If you just made up some random units that you did all your data with, because you're going to have data to back up this cure for cancer, because nobody's going to believe you if you don't have data. Let's say that you just made up some random unit that, you just made it up yourself. No one would believe you because your data would be some random unit that nobody ever understood. It wouldn't make any kind of sense, and no one would be able to use this cure for cancer that you found or created. So what happens is, in the science community, research scientists, really science in general, there is a standard set of units that we use throughout the world. Okay? These are called standard international units, or you could call them SI units. Okay, and there are 7 of them, base units, that we're going to talk about. So I'm actually going to make a chart. This chart needs to go in your notebook. This chart is very, very important when we have your exam, which I think is 2 weeks from today, I think. I have to go back and look. It's coming up. On your exam, I will ask you questions such as, what is the SI unit for mass? And it will be multiple choice, but that's the kind of question that you're going to see. So this chart is extremely important because you're going to have several of those questions on your exam. Also on the study guide, when I do give you the study guide, this chart I will have on the study guide, and you'll just fill this chart out. Okay, so I'm going to make 3 columns on this chart. The first column is going to be the measurement. The second column is the unit. And the third column is the abbreviated unit. Abbreviation. Now, there are 7 of these recognized SI units. One of them we don't really use, but I'll still put it down. Okay, so the first one that I'm going to write down is, oops, excuse me, I dropped my Apple Pen. The first one we're going to use is for length. Okay, I want you to notice that I didn't say distance, I said length. Okay, now the unit for length is a meter, and that's abbreviated with a lowercase m. A capital M in chemistry means something completely different, so you need to make sure that you use a lowercase m. Okay, next on our list is time. Okay, that's measured in seconds. Okay, I know that time has, you could use minutes, you could use hours, you could use days. That's all measurements of time. But the standard international unit for time is a second. So that's like the default setting. That's what we need to use. Now there's 2 ways to abbreviate second. You can do a lowercase s or a lowercase sec. Either one of those are acceptable. All right. Next one is mass. Now this is the one that everybody has a hard time remembering, and this question is on your exam in a couple of weeks. What is the SI unit for mass? The SI unit for mass is a kilogram. This is the only one that uses a prefix. So I didn't say kilometer, millimeter for length. I didn't say kilosecond or a millisecond for time. The only one that uses a prefix like this is going to be mass. So the SI unit for mass is a kilogram, and that is abbreviated lowercase k, lowercase g. I'm going to circle this kilogram because that's a little different. Okay, the next one is temperature. Now, temperature, the one that you're probably used to, the scale for temperature is going to be Fahrenheit. So we're one of the few countries in the world that actually use Fahrenheit on a daily basis. Most countries use Celsius because it's just based off the metric system. It's a lot easier. It's, 0 to 100 is, the basic scale of Celsius. Fahrenheit's kind of all over the place. But in the scientific realm, a more accurate temperature scale is called Kelvin. It is much easier to do things in Kelvin than it is in Celsius and Fahrenheit. So this is Kelvin, and that is a capital K. Now, normally when you deal with Celsius or Fahrenheit, you have a little degree symbol that you put after that. On Kelvin, there is no degree symbol. All right, the next one is going to be amount of substance. Okay, and that is a mole, M-O-L-E. That's abbreviated M-O-L. Now, this, we are not going to get to this till closer to the end of the year. But it is basically what a mole is like, how you have 12 eggs or a dozen or anything that's 12 is called a dozen. A ream of paper is 500 sheets of paper. A baker's dozen is 13. A few is 3, a couple is 2, stuff like that. That's basically what a mole is, but it's 6.022 times 10 to the 23rd particles is what that is. So you don't need to know that what a mole is in general. All you need to know is that the SI unit for amount of substance is a mole. That's all you got to know. All right, now there are a few more that I could cover. We do not cover them in chemistry, so I'm not even going to mention them. You will not be tested over the other 2. One of them is for electricity and the other one is for light intensity, so don't even worry about it. We're not going to use them. All right, so let's talk about a little bit about a few definitions. So I'm going to talk about The definition of a measurement. The amount of something when compared to the standard. Okay, now this is an important point that I want to bring up. So, you know, if you've ever been in my classroom or any kind of science classroom, they've always got these meter sticks that we use all the time to measure stuff. They're just this really long stick with all these measurements on it. Okay, but that whole stick is 1 meter. So have you ever thought about what decides how long that is? Like, how do you know how long a meter is? Who decided that? Who said that? Okay, did some just random person just come up with this and said, okay, everybody in the world needs to have a meter this long from now on? No, that's not what happened. Okay, so I actually want to talk about, so I like to use meter stick because that's one you've seen before. I want to talk about a kilogram for just a second. Like, how much is a kilogram? Who decided this? Why is a kilogram that much? Okay, because we talked about the SI unit for mass as a kilogram. In a place called Sèvres, France, there is a hunk of iridium and platinum called the IPK. Okay, this is what it's called, and you can look it up. IPK. It's made of iridium and platinum. And I used to have a picture of this. I'm sure you could probably Google it. What it is that IPK is the kilogram. That's what that is. Okay, so let me see if I can Google a picture real quick. So what it is that is the kilogram that everybody compares their kilogram to. It is the standard for the entire world. Sèvres, France. Let me see if I can find a picture. Here we go. All right, so if you look at this, I'm trying to zoom in, but it's not working. Hold on, y'all. Okay, so this is the kilogram for the entire world. If you have a kilogram, this is what this was compared to. Now, if you look at the picture here, this big silver thing in the middle, that big hunk is made up of platinum and iridium. That is the kilogram. Now, these other things that are around it are vacuum chambers, because it cannot, even a single atom leaving the IPK will change its mass. So we can't even have that happen. So there are actually 3 different vacuum chambers over this. This is the kilogram. It's the measure for the entire world for how much a kilogram is. Every kilogram that ever was is compared to this kilogram, the IPK. So it's super important. So this is the standard kilogram. All right, anyway, just a neat little fact. All right, so we talked about SI units. We talked about different types of units. Let's see. All right, so let's go on with a few other definitions. Let's talk about length. You should be writing this down in your notebook. Length is the distance between 2 points. Volume is amount of space an object occupies. Mass, we talked about this one before, is the amount of matter in an object. Density is one that may be new to you. So density is how much mass per unit volume. Another one, something that you need to know about, is called a derived unit. Okay, now this is probably one that you've never heard of before. So this is a unit obtained by combining other units. Okay, so this is a different type of unit. Now, the units that we've been talking about so far are either base units or, they're just very, very simple. But what happens when you start combining units? Like when you do speed, because that's distance divided by time, so that's meters per second. What happens when you start combining them? That is a different type of unit called a derived unit. Now, the example that I like to use is actually an example from physics. It's called a Newton. That's a capital N. Okay, so this is actually the unit for force. But what a Newton actually is a kilogram meter per second squared. Okay, like if you were talking about this in physics and you had to say, I pushed this with a force of 17 kilogram meter per second squared. Like that's a mouthful. That's a lot. And science people will try to make it easy on us. So they just came up with another unit. I could say 17 newtons. Like that's so much easier. Okay, but this is a derived unit. A Newton stands for a kilogram meter per second squared. The derived unit just kind of helps you out a little bit. Okay, another definition is going to be time. Like Miss Smith, I know what time is, but here's an official definition. Time is an interval between two units. And the last one is going to be temperature. It is a measure of kinetic energy in a system. Basically, is when we're talking about the kinetic energy, it's the kinetic energy of the particles of whatever you're dealing with, because everything's made up of particles. So the kinetic energy is going to be how fast they're moving. So if they move faster, that means they have a higher temperature. Things like that. Okay, anyway, and this is measured with a thermometer. Okay, so now that you have the basics, I want to talk about how to move between metric units. So let me go back. Let me add one more. You need to know what the metric system is. Okay, the metric system is a unit of measure based on powers of 10. Okay, so here's the example I like to use. If you've ever looked at or helped somebody with tools, you could have like an open-end wrench that's like 1/2 inch or 3/4 or 15/16. Okay, these are fractions. Okay, I don't know about you, but I really don't like fractions. I don't like it. Okay, so instead, this is called standard. Instead, we have things called 15 millimeter, 12 millimeter, 11 millimeter. Okay, these tools use the metric system. They're based on powers of 10. They're whole numbers. So much easier. I don't like fractions. And science people knew this, so we're going to use a metric system because it's easier. Anyway, so that's a metric system. That's the example for that. So I'm going to add another picture, and we're going to talk about how to get between units. Let me make sure I'm getting the right picture here, not a picture of my dog. Okay, I think it's this one. We'll see. Nope, that's not the right one. It was the other one. It's this one. Okay, so I really need to crop this. Oops. But if you notice, this is from a Google Slides presentation. This is actually one of the slides that you're going to do after you get done watching my video. But I want to talk about this for a minute and what this even is. Okay, so when we talk about base units, which is this right here, a base unit is a gram, a liter, or a, what's the other one? Meter. Okay, those are the 3 units that we use. So these are the 3 base units. They don't have any prefixes or suffixes or anything like that. It's just straight up grams, liters, meters. Now, I'm sure that you've heard about kilogram, kilometer, milliliter. I'm sure you've heard all of those things, but they're using a base unit and adding a prefix. So the base unit is right here. Right there is where the base unit is. So this is going to be gram, liter, or meter. Now, liter is a capital L. Now, what you need to know are what kind of order that the prefixes are in. People get really confused with that. So I'm going to kind of talk about what each of these are. Now, the ones that we use the most is kilo. Okay, like kilogram. We use that one a lot. We also use centi, like centimeter, or millimeter, okay? Now, this weird little U thing down here is called micro, and the N down here is called nano. Now, the capital M means mega. All right, and then the only other one that we haven't, no, I think I got them all. 1, 2, 3, 4, 5, 6. Yeah, I got them all. Oh, look at me. Okay. So that's the basics. So let's say that you're trying to measure how tall a can of soda is. Okay, you're not going to use megameters, because megameters are a huge measurement. Okay, you would do something like centimeters, because the height of a soda can is going to be, 4-ish centimeters, somewhere around in there, because that unit makes sense. It's a smaller unit. You're dealing with a smaller object. So it's going to be 4-ish centimeters, okay? I mean, you could have used a meter and you could have said 0.04 meters or something like that. I mean, that's fine, but centimeters kind of matches the length of that object. Now, let's say that you're running a marathon. You're not going to measure that in millimeters, okay? A marathon's what, like 26 kilometers or something like that? Whatever it is now, I don't know. But you're not going to measure a marathon in millimeters. That's going to be like 100,000 million millimeters. No, okay? So you've got to use an appropriate prefix. Okay, everybody, so this should be able to get you started on today's work. If you are lost, please contact me if you have no idea what's going on. Also, in the work that you're doing today, when you actually get to the part where you have to put numbers in the calculator, those questions where you do calculations on, those answers are actually hidden somewhere on the slides, okay? The only reason why I'm giving you the answers is because I want you to be able to check your work to see if you were right. I mean, you're still going to have to do the work. You still got to do a self-check, okay? You've got to do that. That's the only way that you're going to be able to progress. So work the problem and then see if your answer matches my answer. If it doesn't, then that means that you don't understand how to do it and you need to contact me, okay? So hopefully by me doing this, you can see if you're understanding something, see if you're not understanding something. So please contact me if you need any help.